All right. So, what we're going to talk about today is an antiderivative. Interesting, right? So, we know how to take the derivative, but do we know how to find the antiderivative? Meaning, go backwards, go in reverse. So, for example, if I said we had a function, notice it's a capital F, f of x, we're going to call this the antiderivative. So capital F of x is the antiderivative if the derivative of f of x equals f of x. So capital F, take the derivative, and it becomes a function. Well, can I go from my function back to the original? So I'm looking at a derivative, a function. Can I antiderive it? So the opposite of a derivative. Interesting, right? So all of the rules we know, we now need to go in reverse. Weird, right? Okay, so let's look at some examples. There's a couple things we got to focus on. Remember, there's some rules here. I'll post a table so we can see all of these rules, because every derivative we've learned, we now have to undo them. It's a lot, but we're okay. We can do this. So this first one here, if my function is 2x, the antiderivative of that is going to be x squared, right? Because if I drop the 2, subtract 1, that becomes 2x. Yes? So the antiderivative of 2x is x squared. But here's the a question. If this is x squared, the derivative is 2x. But what if this was x squared plus 3? The derivative is still 2x. What about x squared minus 5? The derivative is still 2x. X squared minus 6,492. The derivative is still 2x. So we don't know if there was a constant on the original function. So to take care of this issue, we're just going to say our antiderivative is x squared plus some unknown number. In our next video, we'll talk about how we find that number given an initial condition. So in this case, the antiderivative of 2x is x squared plus c. Just taking a step back here, if you remember the power rule, we drop the 2, subtract 1. Multiply by 2, subtract 1. So the antiderivative, what we're going to do is we're going to take our exponent, we're going to add 1. So instead of taking it away, we're going to add it, and then we're going to divide by the new power. So that's our new power rule. So if you have x to the n, to antiderive it, you add 1 and divide by the new power. We'll practice that. We'll see it. Let's move forward. We got a couple more examples here. And again, it's remembering these derivatives and working backwards. So here, the derivative of 7x to the 5th, the antiderivative, I'm going to add 1 and divide by the new power. So if I took the derivative, 6 times 7 is 42, divided by 6 is 7, minus 1 is 5. Okay, antiderivative here, that's going to be 4x squared, add 1 to the power, divide by the new power. 4 divided by 2 here, we're going to have to reduce, and that's going to leave me with 2x squared. The derivative of 2x squared is 4x. And the antiderivative of a constant, all we have to do is bring back that variable, right? So here's the antiderivative of f of x, but we don't know if there was a constant on there, so we always have to remember plus c. Whatever that constant is, that unknown, we've got to add that to our antiderivative. Okay, here we go. This one's quite a challenge problem. We're jumping in real fast, real deep. Let's see how we do here, okay? If the derivative of e to the x is e to the x, the antiderivative of e to the x is e to the x. So this is just going to stay 2e to the x plus, here I'm going to add and then divide by the new power. So this actually becomes negative x to the negative 1, which we could rewrite as negative 1 over x. Ooh, this one. Secant squared of x. Where did that come from? What derivative? The derivative of tangent is secant squared. So this is minus tangent of x. Plus 1. So add x. Antiderivative of 1 is x. And then I'm always going to remember my plus c. The only way to crank this out is to practice. Think in reverse, taking the antiderivative. And always remember plus c.